This is the fourth and second to last video in the National 5 Maths Statistics series. So far we have learned in video 1 mean, median, mode and range, in video 2 quartiles and semi-interquartile range. In video 3 we learned about box plots, how to draw them and compare them, and the learning intention of this video, the second to last video, is to calculate and compare standard deviation. So definitely the sort of biggest in terms of most marks worthy part of this topic is standard deviation. So as always, let's start with a definition of it. So standard deviation, well, let's think about what that means. So standard obviously has many different meanings, but in this case, if you think about something being very standard, very routine almost, it essentially means average. Okay, so standard essentially means average. And if you think about the word deviation, if you've heard that in a different context, if you deviate from something, for example, if you were to go from point A to point B, but you were to deviate your route, you would change it in some way, or it would be altered by a certain amount or a certain distance or something like that. So standard deviation essentially means the average amount of change, and the key thing is it's a measure of spread. Okay, spread, and a word that we mentioned in the last video, which is consistency. Okay, so standard deviation is all about those two things. So it's about spread and consistency, and it essentially means the average change. The actual definition we're going to look at is standard deviation is the average distance of a value from the mean. Okay, so there's the mean popping back up, which we already know all about. Okay, so if you have a set of data, and if you want to work out this thing called the standard deviation of that data, you're essentially working out, okay, so if you take any given number from that list of numbers, on average, how far away is that number from the mean? Okay, so how far on average is it from the average? Which is a bit of a strange concept to get your head around, but once you've seen some examples, it actually becomes really quite clear. Okay, and it is found by using this formula. So I've left this blank so that we can write it in together. Now, the formula does look difficult and confusing at first, especially this might be the first sort of main big formula that you've learned in National 5, depending on when you're watching this video. Okay, but the good news is it is in the formula sheet, so this is how the formula goes. So the way that it's written in the formula sheet, okay, is this. So we've got standard deviation. I'm doing it in my Sharpie so it's absolutely clear. I'll do it quite big as well. So we've got standard deviation, SD, equals. Then we've got a big square root, which is always fun to begin with. It's equal to a big square root. Then this symbol, which is the Greek letter sigma, open a bracket, x minus x bar, so x with a wee line on its head, all squared, big fraction all over n minus 1. So that is the standard deviation formula. Now, what on earth is all of that? It can look quite difficult if you've not seen it before, but it's actually very, very easy to break down. Okay, so obviously we've got this big thing going over it, which we know is the square root. So I'm just going to label that, but we know that's a square root sign anyway. We've seen that plenty of times. Let's just go through them one by one. So I told you that this is the Greek letter sigma. Okay, so that is called sigma. It is not a backwards E. If you want to think of it as a backwards E, you can, but it is not an E as long as you know it's sigma, and it means the sum of. Okay, so not sum of as in some crisps out of a packet, sum as in adding things up. Okay, so that is what sum of means. It means add up. Okay, you might have heard of things previously in school or in different contexts, people saying, okay, let's do our take away sums or something like that. No, that's not correct. Sum specifically means adding, which we've talked about before. So if you're talking about the sum of things, it means adding them up. The word sum means add. Okay, so that's that first one dealt with. Let's go with the second one, which is this x. We're familiar with x, we've used loads of x's before, but in this context, x means something specific, which is the variables. Okay, which if you've done maths and statistics at this level before, you'll know all about variables, but maybe not necessarily yet. So what does that mean? Well, it basically means the numbers that you're given. So that's the crudest way I can think of it. It basically means the numbers, or I suppose I could say the data points. Okay, I'm just going to say the numbers because in every example you do, the data points will be individual numbers. Okay, so basically the x's in a standard deviation question are the numbers that you're given in the question. Then we've got its little friend, which is x with a hat on. It is called x bar. Okay, it's the way you pronounce it. So it's got a bar on its head, it's not a line or a hat. It's called x bar. And the good news with that is it's actually something we know a lot. It's the mean. Okay, so instead of the question always writing out the word mean every single time, in statistics and in maths we always have little shorthands for writing things, and x with a wee line on its head is pronounced x bar, and it means the mean. And the last thing we need to define is this letter n, which is probably the easiest one to understand. If you were in a maths class and you were told the letter n stands for something, what would you guess? You would probably guess number, and you're correct. N means the number of variables you have in that question. Okay, so the number of variables, or the number of data points, or the number of numbers, I suppose you could say. So if you were told, take, for example, one of the things from our previous videos, what was it, the number of screen time. Okay, so it was, yeah, it was the screen time of 11 S4 pupils or something like that. So in that case, you were given 11 S4 pupils, so n would be 11 in that case, because you were given 11 numbers, so n is 11. Okay, so what we need to do to work out standard deviation is we kind of need to know what all these things are, put them together in this big formula, and we will get a number out the other side, and that's how we calculate standard deviation. So let's just go ahead, jump straight in with an example. You'll see I have my calculator here because it's absolutely necessary in order to do this. I also have a ruler and a pencil and some other pens, because we're going to need all of these things to calculate standard deviation. So let's bump him over there. And let's look at our first example then. So we've got example 1. So Andrew posted a picture on Instagram. Let's move this over. Each day from Monday to Friday, so 5 days, and recorded the number of likes each day as follows. So these are the number of likes that Andrew got. So 42 on the first day, 45, then 51, then 60 on a Thursday, that was a popular day, then 52 on the Friday. Okay, so those are not the best numbers, you know, he could have been getting a bit more likes, but, you know, he'll take it. Okay, so those are the number of likes he got each day from Monday to Friday. So first thing we need to do is we need to calculate the mean number of likes. Now that is a question that you should all be very happy about, because that's very easy to do. We remember how to calculate the mean. You add all the numbers up and divide by how many you've got. So we can definitely do that. And part B, no surprise, is calculate the standard deviation. So let's go ahead and try to do this then. Let's just make sure that's lined up straight. Okay, so let's calculate the mean number of likes. So this is our solution here. So part A. Well, let's add them all up. So if you add up 42, I should say this is for the mean. I'll just write mean equals. So if we do 42 plus 45 plus 51 plus 60 plus 52. So add them all up and divide by how many we've got. Well, we've got 5 days from Monday to Friday. I've got 5 numbers, so I'm dividing by 5. And if you add all those up, you can do that with or without a calculator. Easy enough. They add up to 250. And if you divide it by 5, 250 divided by 5 is 50. So his mean number of likes was 50. You got an average of 50 a day. Because remember, the mean is a type of average. Okay, so that is us. Now, part B, definitely more involved. We're going to calculate the standard deviation here. Okay, so the first thing we need to do when we're calculating standard deviation is we need to draw a table. So I'm going to switch to my pencil and I'm going to use my ruler and I'm going to tell you everything that needs to go in this table. So we start with x, then we have x bar, then we have x minus x bar, in some brackets, then we have x minus x bar, in some brackets, squared. You don't need to draw lines everywhere in this table. I would just do this many. Okay, and we only need to go down 5, like so. Okay. Okay, so that's our table done. Now we need to fill them in. Okay, what goes in the x column? Well, we said over here, you can just about see it, that x was the variables, i.e. the numbers from the question. So that would be these up here. So let's put the numbers in. So we've got 42, 45, 51, 60, and 52. Excellent. Then we've got x with a wee line, but remember, that's x bar, which is the mean. So let's put the mean in here. So the mean is 50 that we've calculated. I've not made that up. That's what we did in part A. So even if the question doesn't ask you for the mean in part A, to work out the standard deviation, this way, I should say, you will need the mean. The next column says x minus x bar. What do we do there? Well, we've got x here and we've got x bar here, so I think we should go ahead and subtract those things. So be careful, 42 take away 50 is not 8, it's negative 8. Okay, it doesn't particularly matter because of what we're going to do next, but maths is maths, let's keep it all correct. 45 take away 50 is negative 5, 51 take away 50 is 1, 60 take away 50 is 10, and 52 take away 50 is 2. The last thing, we've got x minus x bar, x subtract x bar, with a bracket round it and a squared up here. What do we think we do there? Well, this column says x minus x bar. This is the exact same but with a squared, so let's go ahead and square these numbers. Now, I just said a minute ago it doesn't matter if we have a negative 8 there, because if I had 8 squared, that would be 64. If I have negative 8 squared, it's not negative 64, that's still 64. So minus 8 in a bracket squared is 64. Okay, so that should tell you something straight away, that this column here should always be positive. Every single number in it should always be positive. So that's a really important note that you should take just now. You should never have a negative number in this last column. Okay. Negative 5 squared, well, minus 5 times minus 5 is 25. 1 squared, 1 times 1 is 1. 10 squared, 10 tens are 100. 2 squared, 2 times 2 is 4. Okay, and that's our table just about finished. Okay, the last thing that we need to look at, we actually take from our formula. So hopefully, if you've been paying attention as well as taking the notes, you'll notice that this thing here at the top of my column, it says x minus x bar in a bracket squared. Well, we've just seen that over here. This bit here, minus the sigma at the start, is exactly the same as that there, except it's got this sigma at the start, this backwards E looking thing, and that means the sum of, which means add up. So what do we think we do with the numbers in this last column? We add them all up. Okay, so we draw a wee line, we add them, and when you add all those up, let's see what we get. So 64 and 25, you can use your calculator for this, but hopefully we won't need it. 64 and 25 is 89, plus 1 is 90, plus 100 is 190, plus 4 is 194. Okay, and that is us finished with our table. We can now go ahead and calculate standard deviation. So, next thing, let's write down our formula. Hopefully you've memorised it by now. Standard deviation is, I'm going to try and fit all this in, so I might draw it a little bit smaller. Should just about fit it in though. So we've got the square root of the sum of sigma x minus x bar all squared all over n minus 1. Okay, now loads of people get confused at this stage because they think, okay, I've done the table, what do I put from the table in here? Well, this number here is the sum of all the x minus x bar squareds. The top line in that formula is the sum of x minus x bar squared. So this number here, this 194, is the full top line of that formula. Okay, they are the same thing. The sum of x minus x bar squared is that number. So the full top line of this formula, I can just replace with 194. All over. I've got n minus 1. Now, n is the number of variables, which is the number of numbers. You have 5 numbers in the question. I should say you've got 5 numbers in the question here. So n is going to be 5 minus 1. Okay, so n is 5, but we've got n minus 1, so we need to do 5 minus 1. Don't like doing it across the way, but we are running out of space, so I will do it across the way just this one time. So that equals square root of 194 over 5 minus 1. Really difficult that. Gives you 4 equals... And notice that we've done all these difficult calculations, but this is the first time I've actually touched my calculator here. Turn it on, square root button, fraction button, 194 over 4, hit equals, and it gives us this. Now, what we want to do is we want to write out loads of decimal places at the start, and we'll round after. 4139, yep. Okay, so we've got 6.964194139. The question will usually ask us to give it to a particular number of decimal places. If it doesn't, I would go for 2 in this case. Okay, so if we want 2 decimal places, let's look at the third number, which is a 4, which means we're going to round down. So that's going to give me a standard deviation of 6.96. Okay, so the key thing in that question is really where we're just doing the computation now. We weren't talking an awful lot about what that actually means. Okay, so what does that mean? Well, remember what we said at the start. The standard deviation is the average distance from the mean. So we had a mean of 50, and these were the number of likes I got each day. So in other words, the standard deviation tells me that on average each day I was an average of 6.96 likes away from my average of 50 likes. Okay, now that might be slightly confusing to think about, but it does make a bit more sense once we look at the second part of our learning intention, which was, you can't quite see it there, comparing standard deviations, so comparisons. So let's try an example on that then. So example 2. Okay, we have, let's keep that nice and straight. Emma recorded the weights of 4 parcels she had delivered to her house 1 week, and these weights are in kilograms. So we've got 4.8, 5.2, 6.6, 7.4. Okay, part A, calculate the mean weight. Part B, calculate the standard deviation. We are going to have a part C in this question, but not right now. We are going to do it separately though. Let's just go ahead and do this quickly though. We don't want to waste too much time. So let's do the solution here. Okay, part A, the mean. We're going to add them all up and divide by how many we've got. So 4.8 plus 5.2 plus 6.6 plus 7.4. All divided by 4. If you add those up, what does that come to? 4.8 and 5.2 is an even 10. 6.6 and 7.4 is an even 14. So that's 24 over 4, which will give you a mean of 6. So the average weight of the 4 parcels is 6 kilograms. Okay, let's do part B. Okay, let's get the standard deviation. First thing we do, standard deviation, is we draw our table. It goes x, x bar, x minus x bar, x minus x bar squared. If you can't remember what goes in the table, look at the formula in the formula sheet and it will hopefully give you a clue, because as we said, the last column in the table is essentially in the formula. Okay, so if you can actually look at the formula and try and remember it, it will help you. Okay, so what goes in here then? In the x column, that's my variables, so I'm going to put those numbers in. 4.8, 5.2, 6.6, and 7.4. I'll point out you don't actually get any particular marks for the actual working in the table. You only get the actual marks for when you finish the table, but it all matters. X bar is the mean. This is the mean here, 6. So we just put 6 in all of those. Then x minus x bar. This is x bar. So let's do this, take away this. 4.8 take away 6 is negative 1.2. 5.2 take away 6 is negative 0.8. 6.6 take away 6 is positive 0.6. And 7.4 take away 6 is positive 1.4. Now, at this stage last time when we were squaring, we didn't use the calculator. If you want to use a calculator this time, you can, because we've got decimals, and you might just want to check it out for yourself. So if you do 1.2 squared, that gives me 1.44. Now notice I didn't even put negative 1.2 into my calculator, because I know that negative 1.2 in brackets squared is going to be the same as 1.2 squared. Okay, likewise, if I do 0.8 squared, it's going to give me 0.64. Okay, if you know your square numbers, you should be able to work this out as well, because 12 squared is 144, 8 squared is 64. 0.6 squared is going to be 0.36, because 6 squared is 36, and 1.4 squared is going to give me 1.96, because 14 squared is 196. Okay, so we're almost finished. Last thing we need to do, because my formula needs the sum of x minus x bars all squared, we're going to need to add these up. Okay, I would probably add them up in my calculator just to be certain in this one. You don't want to do all the work in the table and then mess up the last bit. And if you add all those up, oops, we definitely don't want cosine. Let's do that again. 1.44 plus 0.64 plus 0.36 plus 1.96 equals 4.4. Okay, that seems reasonable. Doesn't look like we've made any mistakes there. This is almost 2, that's 1.5. They add up to 1. So yeah, that seems fair. Okay, so we've got 4.4 as the end of our table. Let's work out standard deviation then. Should just about fit it in here. Yeah. So standard deviation equals, big formula, square root of sum of x minus x bar all squared all over n minus 1, like that, equals big square root. Remember, the top line in that formula is this number here, so that's 4.4 over n minus 1. N is actually 4 in this case, minus 1. So that's going to give me the square root of 4.4 divided by 3. Put that in my calculator. Square root fraction 4.4 over 3 equals, that's going to be 1.211060142. And again, let's just round that to 2 decimal places this time, which is going to be 1.21. So that's my standard deviation. So on average, my parcels are 1.21 kilograms away from the mean of 6 kilograms. Okay. Right, last part of this question, and this video is getting quite long now, so let's just try and squeeze it in here, is the comparisons bit. So the part C of the question would say something like this. So the next week, Emma's parcels had a mean of, let's say, 7 kilograms and a standard deviation of 0.9. Make 2 comparisons. Okay, so in most exam questions, you'll have a wee 2-mark question at the end which says something like this. Okay, so we're basically going to compare this week to our new week in part C. Well, what are the obvious things you can say? Well, we've got a mean of 7 compared to a mean of 6, and we've got a standard deviation of 0.9 compared to a standard deviation of 1.21. You get 2 marks. One's for comparing the means, one's for comparing the standard deviations. So what will we write? Well, it's not quite enough to say the mean is 7 and the mean is 6. You need to do a bit of analysis there. Remember, the mean is an average. So you would say, on average, in week 2, the parcels weighed more. You don't need to write me a big long essay saying because 7 is greater than 6 and then prove to me that 7 is greater than 6. You just need to say they weighed more because 7 is greater than 6. Then we need to compare the standard deviations. Now this is the important part. What does it mean to compare standard deviations? Well, I said to you right at the start of this that standard deviation is a measure of spread and consistency. If you have a large standard deviation, it means all your data is very spread out. If you have a small standard deviation, it means all your data is very close together and very consistent. So that's what we need to see, and we want to see one of those, if not both of those words in there. So in the second week, the standard deviation is lower. So I would say in the second week, the weights are more, and we'll just fit in my favourite word, consistent. Ideally, I would actually have a little bit more space. I would like to have said a little bit more in those two statements, but we'll see some examples of that in the past paper questions video. We'll do a couple of questions on this in that video, and we can get a little bit more in-depth statements. But in general, there's those two things. I'm actually just going to write it in here. So if you've got a large standard deviation, it means less consistent. And vice versa. Okay, we'll come back to that in the past paper video.